In an equilateral triangle ABC, D is a point on the side BC such that BD is equal to 1 by 3 BC. Prove that 9AD square is equal to 7AB square. This is what I have to prove. It's an equilateral triangle. So let's see the solution. Okay. So this is a triangle. Let's name it A, B, C. So ABC is an equilateral triangle. So equilateral triangle means it's having all three sides of equal length. Now let us take this. Let us draw a perpendicular from A to the side BC and name this. This is a perpendicular. Therefore, this angle here is 90, and here also this side is also 90 degrees. So on either side we have got 90 degrees angle. Now we name this point as a point E. Okay. Then now let us see, we need a certain, before we start proving this condition, we need some theory. So that's why I'm first telling you a little bit of theories here. There is a theory here. The theory is ABC is an equilateral triangle, and when you say ABC is an equilateral triangle, that means side AB, side BC, and side AC, all three sides are equal. And we have drawn AE perpendicular to BC. So this line is perpendicular to BC. So when these two are perpendicular, we will prove that E is the midpoint of BC. If E is the midpoint of BC, first we need to prove that it is really the midpoint. So we take these two triangles, that is triangle AEB, AEB and triangle AEC. In these two triangles, okay, AEB is 90 degrees and AEC is also 90, because these two are 90, because we have drawn them perpendicular. They are 90. Why? Because we have drawn them, they can say it is by construction. If these two are 90, then we have AB is equal to AC. The side, this side and this side both are equal. Why are they equal? Because they are the sides of a equilateral triangle. So they should be equal. Then AE is equal to AE. This particular side, that is AE, this side is equal to itself because it is common to both these triangles. Therefore, it is a common side. Now, when these two triangles are, so this is angle is 90, this side is equal, and this is common. Therefore, these two triangles are congruent by right angle, hypotenuse, and side. So we can say that triangle AEB, triangle AEB is congruent to triangle AEC. That means these two triangles are congruent by, it is congruent by RHS congruency. So RHS means right angle, hypotenuse and side. Right angle, hypotenuse, side congruency. So these two triangles are congruent. If these two triangles are congruent, means BE must be equal to EC. Therefore, we can say BE is equal to EC. If BE and EC are equal, now if you see this figure, what is BE? BE and EC both are equal, but BE and BC together is BC. So if you write like this, because they are, why are they equal? They are the congruent parts of congruent triangles. In short, usually we write it as CPCT. Full form is congruent parts of congruent triangle. Now, BC is equal to BE plus EC. See, BC, this full length is BE plus EC. So, but EC is also equal to BE. So, I write this as BE. So, if you write that, it will become BE plus BE. BE plus BE, what it is? BE plus BE is 2BE. Okay. BE plus BE is 2BE. Therefore, you get BE is half. So take this 2 down, it become half of BC. So BE is half of BC. That means this length is half of the entire length BC. So we are going to use this condition. Okay. If I directly write in, so this part, whatever I proved it, when you are trying to solve this question, you don't have to write this. This is for you to understand why I am going to substitute B is equal to half BC while proving this. Okay. And this one condition is already given, BD is equal to half 1 by 3 BC. So this is, we are using this condition and this condition. Okay. But this condition, it is to be understood that it is when you are in an equilateral triangle, when we draw a perpendicular from the vertex to the base, it will divide the base into two equal halves. Okay. So now let us continue with the question. This is the question. So solution, let's go for the solution. So let's just draw. See, this is a triangle A, B, C, and let us draw the perpendicular. These two are 90 degrees, and this is E, and let us draw a line here and name this as D. So once we have named this as D, so that means this length BD is 1/3 of BC. This much is 1/3 of the entire length BC. Okay, I think it's very clear now. Now let us apply Pythagoras theorem to this triangle ADE. Okay, this small triangle. So see it as in triangle ADE. This is a hypotenuse. So AD square is equal to AE square plus DE square. AD square is equal to AE square plus DE square by Pythagoras theorem. Now let us take AE, keep AE on one side and take this one, this. So it becomes AD square minus DE square. So it becomes AE square is equal to AD square minus DE square. Let us consider this as a first equation. Next. Now let us take triangle ABC, ABE. This ABE, this triangle when you take, so it becomes AB is the hypotenuse, so AB square is equal to AE square plus BE square. Okay, again take this BE to this side, it becomes AE square is equal. This again by Pythagoras we are applying here. So it becomes AE square is equal to AB square minus BE square. Now you see these two equations. You see these two equations. AE square is equal to this. This is also this. So from 1 and 2, both are AE only. Therefore, you can equate 1 and 2. So you get equating 1 and 2 now. When you equate 1 and 2, what will you get? AD square minus DE square is equal to AB square minus BE square. Okay. Now take AB this side. So AD square minus AB square is equal to, this is minus. So when it comes this side, it becomes positive. So that's why it is written in front. DE square minus BE square. Okay. Now AB square AD square minus AB square is equal to DE square minus BE. BE. B to E is BD plus DE. BD plus DE is B. So this is BE square. So here we use A plus B whole square identity for this. So when you try to use A plus B whole square, it becomes A square plus B square plus 2AB. Okay, that is identity you are using. A plus B whole square is equal to A square plus B square plus 2AB. Now there's a minus sign. Let's open the bracket. When you open the bracket, each of these signs will become negative. So it becomes DE square minus BD square minus DE square minus 2BD Now if you see here, this is DE square minus DE square. They should get cancelled. So this and this gets cancelled. So what is left? We are left with minus BD square and this two terms. So write this. What is left? We are writing it down. Now what we do is, let us try to BD 2BD DE it is. So 2BD DE That means BDD, it is 2 times. So BDDE minus BDDE, because minus it is 2 times. So what we do now? So I have written 2 times BDDE has BDDE 2 times. After writing that, so it is, I'm taking out minus BD common. When I take out minus BD common, so the BD square, it is 1 BD outside, so 1 BD inside. Because there is a minus sign, so this sign will become positive. BD is outside, so only DE will remain here. And this also BD is outside. And because minus sign is outside, so this becomes positive. And this is DE. Okay. So now if you see here, so minus BD, BD plus DE. Put this in one bracket plus DE. BD plus DE. BD plus DE. If you see this, BD plus DE is what? BE and DE. So it will be minus BD plus BE plus DE. Okay. So minus BD into BE plus DE. So let's to consider this figure. So minus BD, BE. So now DE, BD plus DE also. Here we had DB, DE. DE is what? DE is called BE minus BD. B, okay, so BE minus BD. So let's open the bracket. So it is minus BD, BE plus BE minus BD. So BE plus BE is 2BE. So it is 2BE. So BE, as I told you, BE is the half of BC. So when you double it, it becomes equal to, so that means 2BE becomes BC. So it becomes BC minus BD. So BC minus BD, let's put the values here. What is BD? We are given BD is equal to 1 by 3 BC. BC minus BD is again 1 by 3 BC. Plus take LCM of this bracket. So suppose this is upon 1, so LCM is 3. So it becomes 3 BC minus 1 BC. So you can write it as 3 minus 1 upon 3 BC. 3 minus 1 is 2. So 2 it becomes, so AD square minus AB square is equal to minus 1 by 3 BC, 2 upon 3 BC. Okay. Now BC is here, BC is here. So we multiply this. So 1 into 2 is 2, 3 3s are 9, BC into BC will be BC square. So it becomes 2 upon minus 2 upon 9 BC square. But BC is the sides of a triangle and we want the answer in terms of AB. So let us change BC to AB. Why? Because AB and BC are equal. AB is equal to BC because sides of an equilateral triangle. So what I have done, I have just changed BC to AB and AB square. So this is also AB square, this is also AB square. Let us bring this one this to the right side. It will become AD square is equal to AB square minus 2 upon 9 AB square. Again take LCM, it is 9 AB square. So it will be 9 minus 2 upon 9 AB square. 9 minus 2 is 7. So it becomes 7 upon 9 AB square. So take 9 this side, it becomes 9 AD square is equal to 7 AB square. That is the what we have to prove. Hope you understood the thing. That's clear. So just subscribe for the but thing, and before you just put a pause.